You guys remember what that acronym stands for? Okay, first one. Yes, ma'am.
Identify the population in question.
Identify the population in question. This is a statistical method. It's how all statisticians approach statistical problems. They identify a population and a question. Yes, sir. D? Yes, sir. Design your experiment, the way you're going to collect your data. You can think of D as being design or data collection. A.
Analyze the data.
Analyze the data. That means you're going to find measures of central tendency. What are the three measures of central tendency? Somebody? Yes, sir.
Mean, median, and mode.
Mean, median, mode. You also need to test, check, and find the measures of variation. There are three of them. Three measures of variation. Yes, sir.
Variation, standard deviation, and deviation.
Deviation, standard deviation, and variance.
Okay.
You had it. Very good. And one more, the spread of the data. How far the data goes is called the? Yes, sir. Range. Largest and smallest. That's analysis. We actually do that. And what do we want to use that analysis for? Those numbers. We use them for something. What do we use them for? I is the hint.
Inferences. Infer.
Infer what? About the population. What we want to know is we want to know a thing called parameters about a population. Anybody remember what this stands for? Mu. And it is the? We don't know it, that's true. It's about the population. It is the population. What does that mean? Average, yes. This is the population average that we don't know. And it is unknowable, usually. Usually the population is so large that there's no possible way we can ever find this. We also might want to know small sigma. This stands for, if it's squared, it stands for the variance. And when we take the square root,
Standard deviation.
Standard deviation. This is what we want to know. We want to know something about a population that it is impossible for us to measure. It is so enormous. Some of you have heard this before, that if you took the population of China, and this is true now of almost any nation, and started walking them into the ocean 2 by 2, at a normal pace, they're just walking into the ocean, and they're all walking into the ocean, you'll never finish. That's how large a population we're talking about. Why is it? Because the line is so long that by the time the people at the beginning, at the end of the line get there, they're already going to have 2 or 3 generations of children. This is something that is so enormous that there is no way to measure it. A good example is the population in the United States of voters. How many voters do we have in the U.S., although it's going down? Maybe 100 million? You guys imagine a million? 1,000,000. That doesn't sound like very many until you take 1,000 people and then take a group of 1,000 of those and then take 100 of those. It's a lot of people. And imagine trying to call all those people and asking them how they're going to vote. By the time you got to the end of the line, the people at the beginning of the line will have changed their mind, or the voting will have already taken place. So we want to know, for example, suppose our population is American voters, and we want to know who they're going to vote for president. And more than that, we want to know what percentage are going to vote for different presidential candidates. For example, we want to know what percentage are going to vote for Hillary Clinton. We want to know what percentage would vote for Rudy Giuliani. We want to know what those percentages are. This is what we want to know. How are we going to find out? We can't ask everybody. Yes, ma'am?
Take a fraction of the population.
Take a small piece of the population. Now, they tried something interesting a long time ago. This happened in the 1930s and 1940s. They were going to have an election, and they wanted to know who was going to win. Was it going to be Dewey or Truman? So what they did was they decided, you know what, we're going to take a big sample. So there were only maybe 1 million voters back then. So they said, you know what, we're going to ask 100,000 people who they're going to vote for, or maybe even 200,000 people. We're going to ask them who they're going to vote for, and then we'll know who's going to win the election. They said a big sample must be better. Doesn't that sound like good reasoning? Mm-hmm. The bigger the sample, it sounds like a great idea. So what they did is they got on the telephone and they called people, and they called and they called and they called and they called, and they got a huge sample. They ended up getting like 20% of the population. And 20% of the population, overwhelming, they knew for sure we're going to vote for Dewey. The next day, the headlines in the newspaper announced Dewey wins. And the election came around and Truman won. Oops. They made a mistake. The mistake was that they asked a very specific part of the population. You see, back then, only rich people had telephones. So all they asked were rich people who they were going to vote for. Well, they were all going to vote for the Republican candidate. But they didn't ask any Democrats. Do you see the problem here? They asked a big sample, but it wasn't random. They asked them for a reason. It was convenient, wasn't it? We call this a convenient sample. Instead of taking a random sample of the whole room, I'm just going to ask these people, and I'm going to use them to represent everybody. If I did that in a place where people chose where they want to sit, it would not be a good sample. For example, if we were in college and I asked just the front row, because you know that in college you get to sit where you want, right? And if I ask just the front row, I want to see how well my students are doing in class, and I ask just the front row, you know what would happen? Everybody in the front row pretty much gets A's. So I would think, oh, my students all understand what's going on. But it's not a good sample. In order to get a good sample, I want to take a random sample from the whole population. And randomness is the important part of this.